The purpose of this lesson is to learn about inheritance, how to extend classes, how to use the protected access specifier, how to override base class members, understanding how a derived class is an instance of a base class, to learn about the object class, how to work with base class constructors, how to use abstract classes and interfaces, how to extend methods, and then recognizing inheritance in GUI-based applications. Sometimes we'll make classes, and what will happen is we'll make one particular type of class and we'll make another one, and the two of them are very similar in design. And what happens when we do this is that we have to completely redesign all of our code for both of those different classes. Sometimes we may encounter things that they are significantly related. The example that I used last time is automobiles. I'm going to continue talking about automobiles this time, but what I'm going to discuss is that I have this class of things called an automobile. Every automobile has things like a number of tires, an engine size, it'll have something like a number of doors, it'll have a color, but not every automobile has a trunk. Not every automobile has a bed. Not every automobile has a steering wheel. Not every automobile has a set of handlebars. So what we're going to do is we're going to figure out what things belong to our what's called a base class, which is going to be the most generic. What do all of these different objects have in common? And that goes into our base class. All right, and then what we're going to do is we're going to allow it so that we can extend the capabilities of the automobile class so that we can add other things to it. So if I have something like a car, then a car could have a trunk. Or if I have something like a convertible, then I can have the type of top that it has. Is it a soft top or a hard top? If I have something like a truck, well, a truck's still an automobile, but the truck also has a bed length. Maybe the truck has a towing capacity. I could have things like motorcycles, so I could have, instead of a steering wheel, I'd have handlebars, so maybe I could have the handlebar type. So what happens is all of my automobiles have these general characteristics that I just simply need to extend on. Alright, so this leads us into the process called inheritance. Now inheritance means that if I declare that we have this class of objects called automobiles, and then I extend that, and I state that we have automobiles that are also cars, and I have automobiles that are also trucks, then what those are what are called derived classes. We also call them child classes because the base, the original automobile, is the parent class. We could also call the automobile the superclass, and then our automobile type of car is a subclass. So we have different terms for it. They all mean the same thing. But the whole point of this is try to save some time. We want to get rid of having to recode the same thing over and over again. So the things that are shared amongst all of those classes would get put into the parent class, and then only the things that are different would get put into the derived classes. Alright, so the way that this one looks, we have an employee here. Excuse me. The employee is defined by an employee number, a salary, and then we have the ability to get and set the employee number, the ability to get and set the employee salary, and then we have a public string get greeting. So when we use this method, we're actually going to state, hello, I am an employee number, and then display the employee number. Alright, so what happens is we may have employees, but we may also have commissioned employees. And what this means is that if we have an employee that receives commission, they're still an employee, so they get all of the basic characteristics of an employee, but then they're also going to get some other things. So you'll notice here's our employee. We have the employee number, the salary, the ability to get and set the employee number and the salary, and then we have our ability to get the greeting. But then we also have a commission employee, and this line right here means that it is a child object. This is derived, this one down here is derived from this base or parent class up here. So what happens is if I create a new commission employee, they will get all of the characteristics of an employee plus all of the characteristics of somebody that receives commission. Alright, so we talk about the base class. This is going to be our top level. This is going to be automobile or employee. or student or school or whatever our generic category is. Then the derived class is going to be things that are going to be added onto it. So if I'm talking about a student, I can have a general class of things that are students, and then we can have a derived class, which are honor students or Phi Theta Kappa students, and those are going to be derived classes. This allows us to do this thing called ancestors, which is kind of like a family tree. The child object relies on the parent object, and this means that the properties and the methods that are obtained by the child are transitive, which means that it's going to receive everything from all of its ancestors. Okay, so I could have my class called automobile with a subclass called car with another subclass called convertible. And what I can do is I could state that, okay, the convertible is going to inherit all of the properties of a car. And the car is going to inherit all of the properties of the automobile. So therefore, a convertible would have properties from all three levels. It would have properties from the convertible level, from the car level, and from the automobile level. All right, so this allows us to extend our classes. And the way that we do this is we're going to declare the class name, and then we're going to put a colon, and then the name of the derived class from where we get our base class properties. Okay, so in this case, we have a class called commission employee. We put a colon, and then we state employee. So this is the base class. This is our derived class. This is our parent. This is our child. And so what this will do is when we actually create a new commission employee, the system will create the commission employee and then look at employee first and get all of the properties from employee. So all of the attributes, all of the methods. If it has a constructor, it gets that. And then what it will do is then it will take and look at the commission employee and then apply all of this stuff. What this does is if they're completely separate properties, then it just simply combines them all together. But let's say I have an attribute here that is the same attribute that is in the base class. Well, what it will do is it'll apply all of the stuff for the base class first, and then it turns around and applies all the stuff for the child class, which means we can actually override things that happen in the base class. All right, so we have this employee. So go back to this. This is a commission employee, which is a derived class of employee. It has a commission rate, and we have the ability to get and set the commission rate. All right, so if we want to call it, we're going to make a new employee called clerk, which is a new employee, uses the default constructor. And then we have a commission employee called salesperson, which is equal to a new commission employee. Now, commission employee, it automatically knows that this person is a commission employee and an employee because in our declaration, we state that if somebody's commission employee, it's a child object of employee. All right, so we're going to make this person called salesperson, which is a commission employee, and the clerk is a regular employee. All right, so the clerk has an employee number of 123. The clerk has a salary of $30,000. The salesperson has an employee ID number of 234, which it received from the base class. And then the salesperson has a salary of $20,000, which it receives from the base class. And then it also has a commission rate, which is defined in the derived class. So then what will happen is if we go back and we want to write this out, we can state clerk.getGreeting, so we display the message for the clerk. And then the clerk number 0 salary, so that's their employee number and their salary formatted as a currency string. It will display that out to the screen, and then we can do the same thing for the other employee, but we also have the ability here to state their commission rate. So what would happen is we get, hello, I'm an employee 123. This is our clerk. Clerk number 123, salary is $30,000 per year. That's all that is made up for the clerk. But our commission employee also has an employee ID number. Our commission employee also has a salary, but on top of that, they also have a commission rate. So any derived class is going to inherit all of the data and methods from the base class. It's also going to include things like private data and methods. So, sorry, what that means is that somebody is not able to call those directly, but when the base class has a derived class, all of those objects are going to be used for the derived class. What this means is that we also are going to need to have some way to allow our base class and our child class to be able to talk back and forth. And so what we're going to do is we're going to start using what's called a protected data field. And what this means is that any child class that gets created is allowed to talk to the attributes directly in the base class, but anybody outside of the child class can't talk to it. We still want to try to use private whenever possible, but we're going to start using protected for some instances, especially where we want the child class to be able to override things in the base class. So it would look like this. We have our class called employee. We have an attribute for the employee number, but the salary is protected. Now, by protected, that means that nobody else can interface with it. So I can't put it in my main method where we try to overwrite this employee salary. Can't do that. But if I make a child class, then my child class can actually directly manipulate this because it's protected. So what happens now is when we get into our commission employee, which is a child class of employee, then we have the ability here to set the employee salary equal to 0 only because employee salary is declared as being protected. So now what we can do is we can do something like salesperson.empsal equals $20,000. And then what happens is in here when we try to set the salary, it will actually try to set it here. All right, so what we end up with is something that looks like this. The salesperson makes $0 per year because we overrode that here, $0. But then they get 7% commission on all their sales. So hopefully they make sales. They'll make some money. All right, we can override base class methods. And what happens is, let's say I have a method for calculating area of an object in my base class. And then in my derived class, I have the same method that allows me to calculate the area differently. Then what I can do is I can override the way that it works in the base class. And this is called polymorphism. Polymorphism is I'm using the same method or property name to indicate different ways to use it. So what we're going to do is I could do something like in the base method I'm going to calculate area as length times width, but in a child class maybe I'm looking at a 3D object in a child class and I want to calculate volume instead. Or I want to calculate area a different way, maybe it's a different type of shape. And so what we can do is in our child class, we can actually define that we want to override how the area gets calculated. All right, so we're going to use this keyword virtual. Now what virtual does is it allows us to actually override the class. So if I want to override something, if I want to allow my child class to override it, I'm going to use the keyword virtual, and that will let me override it. And then in my child class, then I have to state specifically that I'm going to override it. And what that means is that whatever was declared in the base class, we're going to ignore it, and we're going to use this one instead because we're specifically overriding it. All right, so what this lets us do then is we could have something like if we have students and we have paying students and we have scholarship students, the paying students are going to have a certain number of credit hours, but they're going to have to pay for those credit hours. Our scholarship students, they're still going to take a certain number of credit hours, but maybe those are paid for. And by doing this, this polymorphism allows us to actually override whatever happens in the base, and for this special instance of a scholarship student, we're going to let them take these credit hours, but we're not going to charge them anything for it. Sometimes, though, we do need to actually use the method that exists in the base class. And to do that, we're going to use the base keyword. Okay, so now what happens here is in this case, we have a commission employee. And if we ask for somebody to get the greeting, what we're going to do is we're going to allow our base class to turn around and set this string called greeting equal to whatever the base get greeting does. And so what it'll do is it'll turn around, go back to the base and say, hey, what is get greeting? And then it sends get greeting back to here and puts it into this value. And then what it does is it will say whatever is in the base, which is I'm employee number such and such, and then it will add it to I work on commission, and then it returns the greeting. So what we're doing is we're allowing the system to go back to the base, and look at what the base was doing, and then from there we can actually add on to whatever the base method was doing. Alright, so back in our static void, our main, what we're going to do is we're going to make a new commission employee called salesperson, give them an employee ID number, and then we write out their get greeting method. And by doing this, what we're going to do is, hello, I am employee number 345. This came out of the base method, but the new line character and I work on commission comes out of the child class method. And we have this thing called reference conversions, which allows us to take every child class object and actually treat it as if it were the base object. And what we can do is we can always say that a commission employee is a commission employee. And we can also say a commission employee is an employee. And so what we're going to do is we're always going to talk about our more specific being a type of the general class, the base class. And what this lets us do is we actually can perform calculations with them. We can perform conversions. All right, so in this case here we have an employee which is called clerk, which is a new employee. And we also have a salesperson, which is a commission employee. And what we're going to do is we're going to set the employee number for both of these. And then what we're going to do is turn around and display greeting, and we're actually going to send our clerk object over to this method. And you'll notice that it takes it in as an employee data type and calls it EMP. And then what we can do is we can turn around and we can actually write line hi there from number and then emp.emp number. Now, if I take the clerk was an employee, so there's really no big deal doing this. But if I take the salesperson isn't an employee data type, it's, an employee class type, it's a commission employee class type. Well, because commission employee is a child class of employee, I can still treat the salesperson as if they were just an employee. Now, the catch to this is going to be I can only do this if I'm using the characteristics of a regular employee. So like in this case, we only declare the employee number. We're not trying to manipulate the commission rate. All right, so here I take display greeting, send the salesperson over, which the salesperson is a commission employee, which is an employee. So therefore, I can treat it like an employee and do the exact same thing here. And when we do this, then we get something like this that says, hi there from number 234. Excuse me. I'm employee to number 234. Hi there from 345. I'm employee number 345. The object class is going to be our top level class. That's going to be our highest level for all of the objects that we actually create. And what you'll notice is that there is actually a section of code at the top of our programs called system.object. And what we're going to do is we're going to use the system.object to be able to create objects in other classes. And so this is going to be our ultimate base class. And what you'll notice is that when I send data in a lot of our GUI-based applications, when we make them in the Visual Studio IDE, it will automatically make our methods, and it'll say something like object O. And what this is this section of code is going to receive something that's called an object. All right, so my commission employee is an employee, but my employee is an object. So I can always elevate from one level to another. All right, so what we're going to do here is we're going to be able to send over different types of objects. So here we have a paying student, which is a type of student. We have a scholarship student, which is a type of scholarship student. And then we have a clerk, which is a type of employee. All right, so what we're going to do is we're going to send these. Now they have nothing in common. None of the data with them is actually in common except for the fact that they are all objects. So what I'm going to do is I'm going to send over paying student. And then when I send over paying student, it's going to send it and it's going to receive it as an object and call it O. And this is a very generalized way of allowing us to send objects back and forth without actually having to state what their data type is. So I may not necessarily have to state that I'm sending an employee or a student. What I can do is just simply tell the system, hey, I'm sending an object. When I do this, I will get something like this where it just simply allows us to do it. Now the question is, why are we just simply stating that it was called successfully? Well, the answer for it is that a student and a scholarship student and an employee, they all have different properties, they all have different attributes, different methods, different constructors, and so they would have to have things in common here. So I can only do it if their attributes, if I want to play with an attribute with all of them, I can only do it if they all have the same type of attribute, or if they have the same type of method for setting or getting one of those attributes. Alright, so what we can do is we can look at two different objects and see if they're equal to each other or not. So I could send over a student and a student and a scholarship student and see if they're equal to each other or not. I could get their hash code, which means that we could actually see some information about them, and it makes it a little bit easier for us to sort it. We'll get more into this later in Chapter 12 when we start talking about handling large amounts of data. We can get the type of the object, so we could actually see what kind of object it is, and we can also do things like sending things to a string, which we've played with. So these are all methods that exist for the object class. Alright, so if we want to get the type, we can just simply state, I want to know what the type is. So in this case, we're going to do console.writeLine SumWorker.getType, and it will tell us what type of object it is. We can take things and send them to a string, which we've done this before. So what we're going to do is we're going to send, say, like a number, and instead of it being a number, we're going to treat it like a string. We could do things like sending it as currency. We could treat it as other types of formats for the number. We can see if two things are equal or not, and what will happen is it will actually return a true Boolean output if the two of them are equal to each other or not. Alright, so what we're going to do is if the two of them are equal, then they'll be true. Otherwise, it's going to send back a Boolean false. So what it will do is it'll compare the two objects, see if their attributes and their objects are equal to each other, and if they are, then it returns back a true. Alright, so now it will only return a true if the objects actually are equal to each other. So if I have an object that is an employee and another object that's a commission employee, and both of those have the same attributes and both of them have the same methods, then it will return a true. But if they have different methods or different attributes, then it will return a false. Alright, so we can get the hash code. And like I said, the hash code just simply uniquely identifies an object. This is going to be how the system actually keeps track of where our object is, what it is, what kind of data is stored in it, what size is it, what kind of variables it has, and so forth. So the hash code is just simply a way for the system to tell us what the actual object is. So if you do something like create an employee called first, another employee called second, and then tell it to do first.getHashCode and second.getHashCode, then it will turn around and just simply tell us the value for the hash for those particular objects. We can also use constructors with these. Now, when we talk about constructors, we're talking about when we make a new object, what is the system supposed to do automatically when that object gets created? Alright, so we've talked about constructors where we send in data and then we have a certain number of arguments that get sent and have a certain number of parameters that get received. But when we talk about an extended class, what will happen is we have to create the constructor for our base class, and then we also can create the constructor for our derived class. Alright, so for our base class here called employee, you'll see that we have a default constructor called employee, same name as our class, and then with the open and close parentheses. So this is our default constructor, no arguments get sent in. It's just simply if we create a new employee, this section of code will run. And then it'll write out console.writeLine employee constructed. And then for our commission employee, called commission employee, we create a default constructor here called commission employee, which has just open and close parentheses, so no arguments get passed, which means that as soon as I create the commission employee, this section of code will run, and it'll say commission employee constructed. So if I create a section of code that says, hey, create a new commission employee and call it salesperson, notice this over here says new commission employee. This is using our constructor. So now what will happen is the system will turn around and it will perform this section of code. But because the commission employee is a type of employee, it will actually run the constructor for the employee first. So what it'll do is it'll turn around, it'll run the constructor for the employee, and it'll say, hey, the employee was constructed. And then the next thing that it does is it creates it runs the constructor for the commission employee, and then it'll say the commission employee was constructed. So if I make a new salesperson, which is a commission employee, the system will run the constructor for a regular employee first, and then it runs the constructor for my derived class. So when I start using constructors with a base class and a derived class, then what's going to happen is I have to send the arguments into the derived class first. So in this case, let's say I want to set something like my commission employee has a base salary, and then in the constructor of that employee I actually allow my code to set that. Then what will happen is before we can actually set the person's commission rate or their salary or anything like that, we also have to set it in the base class first. So what happens is I'm going to pass my arguments into my commission employee, and it's going to turn around and send that information over to the base class. So if I want to try to set the employee's salary, if you notice for our employee, we have a commission rate for the commission employee, and then we have the employee number and the employee salary here. Well, if I want to create a constructor for the commission employee, I have to call commission employee's default constructor here. And then if I want to set their salary, the salary doesn't exist in here. So what we're going to have to do is we're going to have to take whatever salary I send into it and somehow send it back to the base. And the way that we do this is by extending our constructor. So to extend our constructor, what we're going to do is we're going to display or state the name of the constructor, any arguments that it receives, and then we'll put a colon, and then we're going to use this keyword called base. And what this means is take the following arguments and send them over to the base class. Base is a keyword. We don't have to state the name of the class. So I don't have to say employee here, I just say base. And because a commission employee is a type of employee, it knows that base is employee. So base is the keyword. And then the arguments that we're going to send to it are 1, 2, 3, 4, and then XXXX. So what this will do is it'll turn around. We can set the commission rate here, but if I want to set their employee number, their salary, then we have to send that data over to the base, and then the base is the one that's responsible for doing that. Alright, so we can have these things called abstract classes. So what this is an abstract class is going to be something like a default class where I can't create actual objects, but I can allow objects to inherit properties of it. Alright, so what we're going to do, we're going to use this if we want to allow methods to be created, but we don't actually want the system to make our real objects. So what we're going to do is we're going to have an abstract method which has no method statements. Our derived class is going to override it using the override keyword, and then we end up with something like this. So in this case, we have this abstract class called animal. Pardon me. In our abstract class called animal, we have an attribute called name. We have a constructor for animal that is going to accept something called name, and then it's going to create this.name, and it'll set it to name, and so forth. Alright, well the thing is that our animal can speak, and what we're going to do is we're going to use this just strictly as a way to create some methods that can be used for other objects. So I'm not going to allow an object to be created from this, but I'm simply going to allow other objects or even other classes to inherit properties from this particular abstract class. So in this case, we do have a class of things, which is a dog. It inherits things from animal. So what happens is I can't just simply state that I have an object that is animal. I can't do it because it's abstract. But I can create a child class object called dog, and I can state that it inherits properties from animal. Now, if I were to relate this back to the employee one, let's say we're not allowed to make an object of somebody. We can't have somebody that's just strictly an employee. We can have commission employees, we can have hourly employees, we can have salary employees, but we can't have somebody that's just an employee. Then what we would do with employee pardon me, is we would make employee an abstract class. So that way it has the properties that can be inherited by all those other child classes, but we can only create actual objects from the child classes. So in this case, we're going to have an abstract class called animal. I don't ever want somebody to be able to make an object that is just strictly an animal. I want to force you to use one of the child class objects. So animal is abstract. And then I can have a child class called dog, and a child class called cat, and a child class called human, anything you want it to be. But you can't create an object from the abstract animal class only from dog, cat, human, or whatever other derived classes that we actually have. All right, so in this case, we can have a dog, which is a type of animal. We can have a cat, which is a type of animal. But I can't declare I want to make a new object from animal, because animal is abstract. So this works exactly the same way, but all we're doing is preventing somebody from being allowed to actually create the object called animal. We're forcing them to use the methods that are in animals, but the only way that you can create a new object is to specify that it's an object of one of those derived classes. All right, so we can allow our different types of objects to specify that here we have Spot, here we have Puff, and we're going to display the animal for Spot. We're going to set it over, and creature.speak, if you notice, creature.speak, that's going to be the method for stating if the dog says woof or the cat says meow. All right, so in this case, we're going to send over display animal Spot, and it pulls it in as a data type of animal, calls it creature. And so even though animal is, I can't create an object using it, I can use its data type to specify that other things can occur. I'm not creating an object here, I'm just simply using its data type. And we're going to call it creature, which means we can do creature.speak, and the system will automatically know, okay, creature comes in, it's an animal, but this thing's not just an animal, it's a dog. So when I send Spot, it says wolf. Okay, the next one we send Puff in, it says, okay, animal. All right, well, it's not just an animal, it's a cat, so therefore Puff will say meow, and we still get the same thing. Some programming languages will allow you to inherit from multiple classes or multiple base classes. C# does not allow this, and the reason for it is that it's very difficult to understand. It usually causes problems, and it usually causes trouble when you try to actually create a new class object, especially if one of the base classes gets changed. So be aware that in C# we can only inherit from one class object. Now we can also use what's called an interface, which is an alternative to using multiple inheritance. And what this is an interface will allow us to make a collection of all of the methods that we want to be used. So instead of stating that I have an animal and some other class and I want to allow my dog to inherit from both of those, then what I can do is instead I'm going to make an interface. And so we're going to use the interface kind of like inheriting from multiple base objects, but instead of doing that, we're going to create, we're going to create this interface that allows us to inherit all the same type of properties. All right, so what we're going to do is we're going to use this interface, and in this case it's called iWorkable, and we're going to allow the user to make it where this employee is a child class of the interface called iWorkable. And what this does is it makes it where anything that gets declared for that interface would be allowed to be used by the employee as if it actually inherited all the properties from that particular class. So what you'll notice here is that we have the employee, which inherits properties from the interface called iWorkable, and then we have a constructor. We have a method here called work. This constructor of work does not come from employee, it comes from iWorkable. And what happens is now whenever somebody calls my employee.work, it would actually allow it to perform this section of code, which says I do my job. It returns that. And same thing with animal. So if I have an animal and I have a section here called work, then if somebody calls an animal for work, it'll say I watch the house. For the dog or for the cat, it'll say I catch mice. Now remember, our animal is our base class. It's abstract, which means we can't actually create the object. So we're just simply going to state that we have the ability to use work, but we're only going to allow work to actually do something in the child objects. All right, so what we can do then is we can create a new employee called Bob. We send in Bob as part of our constructor for it. We have a new dog called Spot, and we send in the word Spot for our constructor for the dog. And then we create a new cat, and we send in Puff for the default constructor for it. So now what will happen is Bob.name, it will actually list Bob's name, which is Bob here. And then it says Bob.work. Well, what does Bob.work do? Well, Bob.work says, I do my job. Okay, and then we have Spot.name, which will display Spot. So Spot says Spot.work. Well, what does Spot.work do? Well, Spot was a dog, so Dog.work will say, I watch the house. Then the last one says Puff.name. Well, Puff was the cat, so it'll say Puff says Puff.work. Well, what was Puff.work? Well, it knows that Puff is a cat, so it'll say Cat.work, I catch mice. So when I actually perform the output for this, Bob says I do my job, Spot says I watch the house, and Puff says I catch mice. We've been talking about class objects with all of these examples, but one thing you need to remember is all of this can occur with almost any type of object. And in C#, almost everything is an object. It's either an object or it's a data type or a literal. Alright, so what we're going to do is we can actually take things like variables and we can extend the abilities for what a variable can do. Alright, a variable is nothing more than a namespace in memory, but our variable actually can have actions that it can do. We've already done it before when we do things like a .toString. We're taking some variable that looks like a number, the value in it looks like a number, and we're converting it to something that looks like a string, and then we format it a certain way. Well, that's an extension method. Alright, we can write our own, and the way that we do this is by using a method declaration that looks like this. So we're going to say public string add, and then whatever the name of the object is, and there's a keyword called this. Now you remember this just simply references the memory location of an object. Well, in this case, this references the memory location for this object, which just happens to be a variable or whatever it is we're manipulating. Alright, so what we're doing is we're using a parameter list just like we do with any other method, but we're stating this keyword. And so what it will do is, let's say in this case I have a static class here. Now the static is going to be a requirement. It has to be static because remember, we can only call it by name if it's static. Alright, so if it's static, then what we can do here is we can say in our void main we have an account number which is 49, and then we have a revised account number is equal to, and then notice we have account num dot. Now account num was 49 up here. So account num dot add check digit. Now what we've done is we've now provided a method to be performed on this variable up here. This is like when we do the .toString. Alright, so what we're going to do is as soon as we see this section of code, it comes down here and it says, oh hey, here's a method called add check digit. And it says this int num. Now this is the memory location for this class. Alright, so this is the memory location for the whole class here. Alright, so what we're doing is we're looking at this entire class as an index card for the same type of analogy that we used before for our objects and classes. Alright, so we are going to actually take this and treat these variables as if they're attributes for an object. And then what it will do is it'll do add check digit. And so it comes down, we send 49 in, because it knows 49 came from account number. And then it'll say int first is num, so 49 divided by 10. Then the second is going to be our the modulus for whatever the second number is, so num divided by 10. And then the third is going to be the first plus the second modulus, and then 10. And then our result is going to be number times 10 plus whatever the third object is here, and then returns the results. Then that gets sent back up here. So what would happen is we started off with an account number of 49, but after all that other stuff occurs, the account number gets a new digit at the end of it. Now it has 493. So just simply a method for calculating an additional digit for this. But the whole point of it is that we can take the variable, for account number, and we can actually extend its own capabilities by adding this extension method. When we do this, it just simply gives us a new account number, because we've told it how to extend the capabilities of that particular variable. All right, so we start playing with GUI applications. One of the things you notice is that we play with forms. Most of the stuff we do are forms. All right, so our form is going to be a descendant of this class of objects called forms. So we have our forms-based application is a member of the system.windows.forms. And then we have something like form 1, form 2, or FRM main, or whatever we call it. So what we can do is we can always reference that our form is a child class of the form, child object of the form class. All right, so in this case, when you look at the code for a particular form, you'll see a line that looks like this, and it says public partial class, and then form 1. That's the name of your form, colon form. That means that form 1 is a child object of form, and therefore it will receive all of the attributes and all of the methods of form. So why do we care about this? Well, what would happen is if we didn't actually do this, for every single form that we have, we would actually have to declare what the form looks like, what its attributes are. We'd have to declare all the things that it can do for every single form. And instead of doing that, what we're going to do is we're going to take the base class of form and we just simply add on to it. So it saves us time. It saves time in development, saves time in testing. It allows us to just simply add new features to it without modifying how a form actually functions. And then what happens is behind the scenes, our actual form maintains its integrity and it will always function as if it were a form. We're not changing how a form works, we're adding capabilities to it. We're going to continue working with the example of automobiles. And what I want to do is I want to create a program that allows me to declare some automobiles, but also to declare different types of automobiles. All right, so what I'm going to do is I'm going to copy my template, and I'm going to rename this to Pringle underscore week 12 underscore number 1. And here's my default program. So what I want to do is we're going to create a new class. Now this new class is going to be called automobile. Square brackets, curly brackets. All right, and my class of automobile has things like an engine size, a number of tires, and a color. Now there's a lot more stuff involved in an automobile, but for this example, those are the 3 that we're going to use. So I'm going to make a public double called engine size that has a get and a set method. We're just using the defaults here for this. Public, and it's going to be an integer for the number of tires, which is going to be a get set, and a public string for the color. Alright, so that's my basic automobile. Now if I want to make a new automobile, then what I'm going to do is I'm going to come up here and I'm going to say automobile, and then I'm going to give it a name, so I'll call it auto1 is equal to a new automobile. Okay, now if I were to do this, it just simply creates the object itself, and none of the values are filled in. So I want to fill in the values. Okay, the way that I could do it is I could do auto1 dot engine size is equal to some value, so let's say like 2.0, and I could do auto1 dot and then num tires is equal to 4 and so forth. Or the other option is we're going to use the shorthand notation. So I'm going to do it the shorthand way. That way, for the sake of this particular exercise, it's a little easier to follow. All right, so what I'm going to do is after new automobile, I'm going to specify in curly brackets that the engine size is 2.0, the num tires is equal to 4, and the str color is equal to silver. Alright, so now I have a new automobile, and if I want to display the information about that automobile, then I'll do something like console.writeLine. And then what am I going to write? Well, I want to write out the engine size, and I'm going to put engine size, and that's going to be, 0. And then I want to make a new line character, so I'm going to do a /n, and then the next thing is going to be the number of tires. And this one's going to be 1. n, and then I want to do the color. So color is going to be 2. All right, so now what are those representing? Well, they're representing auto 1 dot and then engine size, auto 1 dot and then num tires, and auto 1 dot and then the str color. I'm sorry. Sorry, I called it str color down here. It should just be color. Okay, so auto 1 dot color. All right, so this should also just be color up here. Okay, so what I'm doing is specifying that my automobile has an engine size of 2.0, a number of tires is 4, and the color is silver. And I want to display the engine size is the engine size, number of tires is auto1.num tires, and the color is auto1.color. So this will allow me to display the information to the screen, and I can actually see the information about the car. So let's try to compile it. Okay, it compiles, so let's go ahead and run it. And there we go. I get my vehicle with an engine size of 2, number of tires is 4, and the color is silver. Now this is a double, but because I did 2.0, it will truncate it. It's okay for this example. Alright, so what we've done is we've created an automobile. Now the thing is that my automobile here has the engine size, has the number of tires, and has the color. But I have different types of automobiles. We have things like motorcycles and cars and trucks and a whole bunch of other types. Alright, so what I want to do is I want to extend this a little bit. And to extend it, what I'm going to do is I'm going to make a new class. So actually, I'm going to go ahead and make a new one. So I'm going to save this as number 2. Alright, so I'm going to extend my class by doing class, and then what am I making? Well, I'm going to make a car. And my car is a child object of automobile, so to specify that I'm going to put a colon and then automobile. Okay, so then my car is going to have some additional features to it, like it'll have a trunk size. So I'll do a public double, and then I'm going to call it trunk size. And the trunk size has its get and its set. Alright, and then I also want to have another class of objects called truck. So I'm going to have class truck, which is a child class of automobile. And my truck has a public value, which is going to be bed length. And the bed length is also going to have a get and a set. Okay, so now what I've done is I've effectively said that I have this class of things called automobile. And the class of things called automobile have things like a car and a truck. And a car is a child object of automobile. So what will happen is if I declare a new car, it will declare a new automobile and then also declare the stuff for the particular car. Alright, so what I'm going to do is I'm going to go ahead and declare a couple of different vehicles up here. So we're going to do a new car, and I'm going to call it car 1. And we're going to set this equal to new car. Now it's not automatically showing me the word car because this car is only 3 characters in length. Okay, and I want to give it some initial values. So we're going to do engine size is going to be equal to 2.4. The number of tires is going to be 4. Color is going to be red. And then we also have one additional value, which is going to be trunk size. Okay, so the trunk size for this one is going to be, say, like 9.3 cubic feet. And then we're going to make another car. This is car 2, which is going to be equal to a new car. And it will also have some initial values. So it'll have engine size is 1.3, so it's a little engine. Number of tires is equal to 3. This is a small 3-wheel vehicle. Its color is yellow. And it has a really small trunk, so its trunk size is 1.2 cubic feet. Alright, then I also want to declare some truck objects. So I'm going to make a new truck, and I'm going to call it truck 1. And that's equal to new truck with the default constructor. Okay, now this will also have an engine size, and the engine size for this truck is 4.8. The number of tires is 4. The color is black. And this time we don't have a trunk size, we have a bed length. And the bed length is going to be 5.8 feet. Alright, so then I'm going to make another truck, and we're going to call this one truck 2. And this is a new truck. And once again, it does have an engine size. Its engine size is 5.6. Num tires. This one's 6 tires. Maybe it's a dually. Color is equal to white. And bed length is equal to 8.0. Okay, so now what I have is I have one regular automobile. I have 2 cars and 2 trucks. And what I want to do is I want to start displaying information about them. Now they're all going to be formatted about the same, so I'm going to cheat and just copy this line here. Okay, so in this case it's going to be not auto 1 but car 1. So I'm going to change all these to car 1. And what happens is our car has an engine size, our car has a number of tires, and our car has a color, but it also has the trunk size. So we're going to call this 3. Alright, so then what I can do is 3 is going to be car1.trunk size. Alright, so I want to run this just so you can see what happens, and then I want to make a change to it. So I'm going to go ahead and compile it. Alright, so this time we are working with number 2, so I'm going to compile number 2. And then I want to run number 2. And now you'll see that I have a car with an engine size of 2, a number of tires is 4, color is silver, the engine size for the next vehicle, the car, so this is automobile with no trunk size, this is now car 1, does have a trunk size. So it gets all of the characteristics of an automobile plus the extra stuff that a car has. Now I want to make this look a little bit nicer, so what I'm going to do is I'm going to add a /n at the beginning of this, just so that way we can have a line break in between the cars, or in between the automobiles. Alright, so here's my automobile, here's my car. Now I also want to show you something else, which is that for each object that we have, everything will get a hash code. It will actually have an identifier for the particular object. So I'm going to add something to the beginning of each of these. I'm going to say hash, and then we're going to make this 0, which means I need to increment each of these. Okay, and then what I'm going to do is I'm going to add auto1 dot, and then how do I get the hash? Well, I'm going to say something like get hash code. And then now what this will do for me is it will actually show the hash code for this. So let's do the same thing for this one. We're going to say /n hash, and this is 0, so I got to change the rest of these. This would be 1, this 2, this is 3, and then now this one's 4. And we're going to do car1 dot get hash code. Alright, so let's go ahead and compile it. And now when I run it, now what I get is the hash for each of these things. So I must have done away with the /for engine size, and I did. So I need to put that back. Make it look a little nicer. Okay, so now you'll see that each object has a different hash code. So every time you create the program, it will automatically assign a memory location. It will assign something to uniquely identify this object. So this is, in this case, the object's identifier to the system. So here's the hash. This vehicle has an engine size of 2, 4 tires, color silver. My car, though, also has the trunk size. Alright, so I can start adding to this a little bit more. So what I'm going to do is I'm going to come down here and I'm going to cheat one more time. I'm going to copy this because this is a car. And in this case, this is going to be car 2. So I'll go ahead and change every one of these to car 2. And car 2 trunk size. Okay, so now if I compile it and run it, now I have my first vehicle, it's just the automobile. I have the car 1 and car 2, and you'll notice that both of these have the trunk size because these are cars. Automobile does not have a trunk. Car does have a trunk. Alright, so I also want to get my trucks. I want to see those. So I'm going to cheat one more time, copy this, modify it just a little bit. Okay, so in this case, we don't have a trunk size. This time we have a bed length. And in this case, it is truck 1. So truck 1 for each one of these. And this one is truck 1 dot, not trunk size, but bed length. Okay, I'm going to do the same thing here. Copy this again. And we want to see the information for truck 2. Okay, so now if I compile it and run it, now what I'll see is that I have all 5 of my vehicles. So if I scroll up just a little bit, here's my automobile. That's the regular automobile class. Then I have my car 1, car 2, truck 1, and truck 2. And you'll see that the trucks have bed length 5.8 and a bed length of 8. So they all inherit the same characteristics of an automobile. They all have an engine size, they all have a number of tires, and they all have a color. But the car adds the trunk size. The truck adds the bed length, and we just simply can reference those. So what it will always do is it'll always declare the automobile first. So even for this car, all of the automobile stuff gets declared first. And then it will declare the trunk size. The truck, same thing. The engine size, number of tires, and the color, those come from automobile, so those get declared first. And then the bed length will get applied next. So the order of inheritance is always going to be the parent gets applied first, then the child information gets applied next. All right, so I'm going to go ahead and save this as number 3. In number 3, what I want to do is I want to show you what would happen if we played with an abstract class. So in number 3 here, what we're going to do is we're going to come down to automobile, and instead of just being class automobile, I'm going to make it abstract. Okay, so now what this does for me is it makes it where I cannot create a class object called automobile. I can only create class objects that are car and truck, but car and truck can still inherit stuff from here. Alright, so I'm going to go ahead and save this, and I want to try to compile it. So this was number 3. And what you'll get, it says, cannot create an instance of the abstract class or interface program name .automobile, and it's on line 11. So if I come here and look at line 11 is the line where we actually try to make a new automobile. So what I'm going to do is I'm going to do away with this line. All right, if I do away with that one, I also have to do away with the one where I display information for it. So now what I have is I have a car, and I have 2 cars, and I have 2 trucks, but nothing is declared as being just an automobile. And then when I display things, I only display things about the car and the truck, because I can't make an actual instance of the automobile class because it's abstract. So what I'm going to do is I'm going to try to compile it now, and it will let me compile it. And if I try to run it, I still get where I have my cars and my trucks. But because I made my automobile class abstract, I cannot actually instantiate an automobile. I'm forcing people to select what kind of automobile it is. So in this case, you still have automobiles, you still have cars, you still have trucks, but we can't declare an automobile directly. We have to declare one of the child class objects. In this lesson, you learned that inheritance is the principle that allows you to take information from a general category, such as automobile, and apply it to more specific objects, things like our truck or our car. You learned about the base class, which is also known as either the superclass or the parent class, and then the derived class, which is also called a subclass or a child class. To declare a child class, we're going to put a colon between the name of the derived class and the base class. If we want to be able to reference attributes that exist in the base class, we need to use the protected access modifier. Derived classes will exhibit polymorphic behavior. So if I have a method in the base class and a method in the child class and they both have the same name, then I have the ability of overriding how the method works in the base class. However, if I do want to use the one that's in the base class, I have to use the keyword base. Every derived object is a specific instance of both the derived class and the base class. Every class derives from system.object. That is our topmost level of our objects. Whenever we instantiate an object of a subclass, we have two constructors, one for the base class and one for the derived class. Make sure you're aware that the base class constructor gets run first, then the derived class. Whenever we make a header for a derived class, we can provide arguments, and then we can pass those arguments over to the base class. And once again, we use the keyword base for that. An abstract class is one where we cannot create an actual object from the class, but we force the program to create objects with the derived classes or the child classes instead. C# does not allow multiple inheritance, but we can use interfaces instead. And then we can also provide extension methods so we can add to capabilities for any of our other objects or our variables.